Welcome to our tutorial for data analysis with the R package dplyr, which is a package that is a part of the tidyverse core. Recall that this is the same tidyverse core that houses the reader package. As always, here are the instructions for this tutorial and the associated Google quiz. There will be quiz questions and try-it-yourself questions that you can solve to test your understanding. Here are the learning objectives as well. But in short, this tutorial will cover very powerful functions in the package dplyr that we can use for data analysis. And some of the functions that we will be covering today are rename, select, filter, arrange, mutate, transmute, and summarize. The first step is always going to be setup. Here is where we will be installing and loading the required packages. So for this tutorial, we need the package dplyr as well as the package enhance A because we will practice simple analysis on a few enhanced datasets. The next setup step that we're going to do is to set our working directory. Again, by default, our working directory is the folder that our current R session is connected to. You don't have to do this step if the current directory that your R session is in is already the desired working directory. Next is going to be importing our enhanced datasets. So for this tutorial, we need two enhanced datasets, demographics and blood pressures, both from the years 2013 to 2014. So that's demo_H and bpx_H. And let's run these codes. If you are unsure why these are the names of our datasets, it is suggested that you revisit tutorial 3, where we go over enhance specifically. Now that our datasets are imported, let's explore them a bit more before we analyze them. So let's first check the dimensions of the two datasets. And we can also check the first few rows and the last few rows. So now that we've looked at the first and last few rows of our datasets, you should have already noticed that our datasets have a few NA or missing values. In the real world, missing values are unavoidable. There are many reasons for missing values. It may be a result of a non-response or incorrect data collection, and it happens all the time. So it's always a good idea to check if there are any missing values before we proceed with our data analysis. In a data frame, you will see NAs if there are any missing value. And NA just indicates that there are missing values. To check if there are any missing values, or NAs, in a data frame, we can use this function right here, is.na. Here we should be able to see our entire dataset with true or false values only. And false means that that specific data point, like there is a specific value. Everywhere that you see true, it means that that data point is missing, or that is an NA value. And we can also nest our functions like so to see how many missing values we have in our dataset. And also we can write functions like these to see if there are any missing values in a particular variable in our dataset. And here's also what the summary table looks like. And we have already covered this function in tutorial 1. So that concludes our part 1 of this tutorial. Again, there are function debunked sections as well as more written descriptions of the workflow of this tutorial that you could read on your own. These are also the quiz questions, and now you should pause this video and do questions 1 to 3 of this quiz now. Now that we've successfully imported the two datasets and have explored them a bit further, we are now ready to do some data preparation. And then afterwards, we can start analyzing our data. So this section right here details a few things that we should keep in mind when we are preparing a dataset for data analysis. In a nutshell, there are 3 core issues with the original datasets that we have. First of all, they're very big. They contained lots of rows and lots of columns. Second of all, there are categorical values, variables that are not recognized as categorical by R. So for example, variables like gender, race, and education level in the demo dataset are all categorical. But since, let's look at this table right here. But since each category is assigned a number, like so, R misunderstands these categories as continuous and numerical data. And the third issue with our current dataset is that the variable names are very long and ambiguous. So we will also try to change the name of some of the variables so that they're clearer and more comprehensible. So how do we tell R that some of the variables in our datasets are categorical? Well, one way is that we can use the function enhanceTranslate in the enhanceA package. And we've already covered this function before in tutorial 3. So we can use this function enhanceTranslate to translate the categorical values. And it's quite simple. You only have to write these codes. And now if we look at our table, all of the categorical variables like gender and race are now recognized as text values instead of numerical values. So to briefly address the first issue and to make our datasets a bit more manageable, let's also use the function select to only select a few variables that we are interested in. So only these variables will be kept. Let's say we want to keep these variables, so we would use select, and then inside the select function we will need to specify the dataset or the data frame, as well as a vector of all the variables that we want to keep, like so. Now our new table, called new_demo, is so much nicer and more manageable. Lastly, let's rename the header or the variable names so that our variables are a bit more easy to understand. So to do that, we will need to use the function rename, like so. And this function is very easy to use. After rename, we need the data frame or the dataset name as the first argument. And then after that, it's just a series of the new variable name, $, and then the old variable names, like so. And now if we look at our final table, everything is very nice and clean and easy to understand. Now we can go ahead and really address the first issue of our datasets, being way too big with too many rows and columns. So we've already selected all the variables that we wanted from this dataset, which means that we already reduced the number of columns in our new table. But for the purpose of this tutorial, just to make everything easier, let's also filter out some of the rows. So let's only select the first 10 rows of our new _demo dataset and work with those 10 rows for the rest of our tutorial. So to do that, we will need to use the function head, like what we've learned in tutorial 1. And then let's also save that new table into a new table named final_demo. And now we should be able to, start doing some data analysis. So this is the functions debunked section where we go over in more detail some of the functions that we've covered in this part of the tutorial. Here are also the try it yourself sections and the quiz questions. It is suggested that you pause this video right now and try to solve these sections before moving on.